Yesterday, literally yesterday, a company called LMArena raised around $150 million at roughly a $1.7 billion valuation. Their business, running the leaderboard that tells you which AI model is best. Also yesterday, a viral article described that same leaderboard as a cancer on AI, arguing that it rewards style over truth and lets models win by being confident and verbose rather than accurate. 3 days ago, a benchmark scandal broke. Researchers and insiders described how major labs can cheat a little bit on public rankings by testing many internal model variants on these arenas, then only releasing the winner. 5 days ago, NVIDIA's CEO was on stage talking about DeepSeek, an open-source Chinese model that is dramatically cheaper to run and has shaken confidence in expensive frontier models. And this morning, most companies are still choosing AI models based on leaderboard rank, marketing, and hype. This is The Intelligent Founder, and in this first episode, the focus is simple: why your company is probably choosing AI the wrong way, and what to do instead. About 40 days ago, when DeepSeek Math V2 was launched, the story looked very different. A model optimized for proof quality and reasoning, not for generic benchmark scores, suddenly matched or beat human Olympiad-level performance in math while being much cheaper to run than many frontier alternatives. That caught my attention because it quietly proved a point. If you optimize for the right real-world metric, you can get both better outcomes and lower cost, without chasing leaderboard scores. So, when I initially did this research, my questions were like, how much are these benchmarks contaminated or gamed? Why do so many AI projects look great in slides but fail in production? What are the metrics that actually track business value, not just test set wins? Since then, so much has changed. In the last few months, several major surveys and reports have all pointed in the same direction. Large shares of AI projects never reach scale or meaningful ROI, with success rates often reported in the 5 to 30% range across different studies and analyst houses. Many organizations say they've adopted AI, but only a small minority see clear, measurable financial impact across the business. So the situation today looks like this. Money flowing into AI has never been higher. Public leaderboards are more influential and more distorted than ever. And yet, most enterprises are not getting the value they expected. And that's exactly why this episode exists, and it's also why I'm starting this podcast now, where along with the long-form deep dive text posts, I can share these moments. Almost every week, there will be one focused investigation, one important AI or tech story that's breaking now, what actually changed beneath the headlines, and how a leader or founder should respond if the goal is real business value, not just looking smart on LinkedIn. In this first episode, we'll discuss why benchmarks are failing you, how leaderboards get distorted, and how to pick models using your own metrics instead. We'll then find out what are those 5 metrics that can actually drive ROI. And finally, we'll build a simple, reusable playbook to evaluate which model to choose for our AI deployment. All right, let's start with the DeepSeek story. In late November 2025, DeepSeek released DeepSeek Math V2, a specialist model for mathematical reasoning. It did something extraordinary. It scored 118 out of 120 on the Putnam Mathematics competition, where the best human scores are around 90. It achieved gold-level performance on the International Mathematical Olympiad. It used a self-verification approach, focusing on the quality of the proof and reasoning, not just the final answer. Reports also highlighted that DeepSeek's approach was much cheaper to run than frontier closed models. The key insight is this: DeepSeek did not aim to get the highest score on generic benchmarks like MMLU trivia or general code tests. Instead, they optimized for a real metric: the logical rigor and reliability of mathematical proofs. In other words, they optimized for what actually matters in that domain. And by doing that, they ended up beating almost everyone on the benchmarks anyway. This is the first big theme of this episode. When you optimize for real-world value, you often get benchmark wins as a side effect. When you optimize only for benchmarks, you often get neither. Now, what's wrong with normal AI benchmarks? Over the last couple of years, many papers have shown benchmark contamination. Test questions are often present in the training data of large models. One 2025 line of work measured contamination rates of over 60% on some popular benchmarks. That means models are often recalling answers they've seen before, not reasoning from first principles. It's like taking an exam where half the questions were in your homework, word for word. Studies comparing traditional benchmarks with more careful contamination-limited tests show a sharp drop. Models that score around 90% on contaminated benchmarks can fall below 70% on cleaner, updated ones. At the same time, large shares of enterprise AI projects show no measurable return on investment. The issue is not that models are too weak, it is that organizations evaluate and integrate them poorly. So we have two linked problems: benchmarks that are easy to game and often measure memorization rather than capability. Business decisions that rely on these scores leading to high failure rates and low ROI. This is why the DeepSeek Math V2 story matters so much. It is a working example of a different philosophy. Choose and train models around the right metric that matters, not the leaderboard. So, if benchmarks and public leaderboards can mislead us, what should founders and executives measure instead? Across recent industry work, 5 practical metrics stand out. These align with how successful deployments, like fraud detection or medical AI, are actually evaluated. Instead of asking what's the model's test score, now let's ask, how does it perform on these 5 metrics for our specific use case? First, success rate on your own tasks. How often does the model produce a usable result on real company inputs? Your emails, tickets, contracts, and code, without heavy manual fixing. Second, cost per successful outcome. Not the price per API call, but total cost per successful task, including retries and human review. Here's a simple example. Model A costs very little per call, but only succeeds 80% of the time. Model B costs more per call, but succeeds 98% of the time. If a human fix costs real money, Model B can end up far cheaper per successful task once you include the cost of failures and rework. Third, instruction following fidelity. Can it reliably follow detailed multi-step instructions? For example, and I just summarize this contract, highlight risky clauses, then propose 3 edits. Fourth, predictable failure modes. When the model doesn't know, does it say so, or does it hallucinate with confidence? Reliable systems fail transparently. That matters if you're in finance, healthcare, or law. Fifth, stability over time. Does performance stay stable after the provider updates the model, or does it drift and silently break your workflows? These are the metrics used implicitly in serious deployments. In fraud detection, the key numbers are fraud caught, false positives, latency, and cost per transaction, not a general benchmark score. MasterCard, for example, analyzes 143 billion transactions annually. Their AI catches fraud in under 50 milliseconds. In the UK alone, they recovered £480 million in fraud in 1 year. They achieved an 85% reduction in false positives. Cards wrongly declined. Did they choose the model with the highest MMLU score? No. They chose the model that optimized for fraud detection rate, customer friction, latency, and cost per transaction. None of those metrics appear on a leaderboard. In manufacturing, the value is reduction in downtime and maintenance cost, not a generic accuracy percentage. BMW had 2 predictive maintenance models. Model A was 95% accurate. Model B was 87% accurate. Which one did they deploy? Model B. Why? Because Model A had false positives. It cried wolf. When you cry wolf, operators stop trusting the system. The whole thing fails. Model B? Lower accuracy, but it never gave a false positive. It prevented 500 minutes of annual downtime and saved £11.3 million at one plant. In medical AI, regulators and hospitals care about sensitivity, specificity, safety, and patient outcomes, not trivia scores. The FDA has cleared over 950 AI-enabled medical devices. Not one was chosen based on an MMLU score. Example, IART for diabetic retinopathy detection. It achieved 97% sensitivity. Human specialist on the same cases, 59.5% sensitivity. It wasn't validated by how well does it answer trivia questions. It was validated by does it save vision in real patients. These are also the metrics that connect directly to ROI and can help you avoid becoming part of that failure statistic. To keep this practical, here's a simple, reusable playbook you can use right now. Step 1. Pick 3 to 5 real use cases. Not AI everywhere. Choose a small number of high-value specific tasks. Customer support replies, contract review, forecasting, internal knowledge search. Step 2. Build a small golden set. Create a set of 20 to 50 real examples from your business. Actual emails, tickets, documents, or code, with clear definitions of what good looks like. Step 3. Test multiple models on your data. Run several models in closed and open through the same golden set. Don't rely on their public rank. Measure the 5 metrics for each. Step 4. Calculate cost per successful task. Include retries and human review. Look at how often you get a good result end-to-end and what that really costs. Here's the math. Say you're choosing an AI for customer support. Model A costs 2 cents per call and succeeds 80% of the time. That's 2.5 cents per success. Model B costs 5 cents per call and succeeds 98% of the time. That's 5.1 cents per success. Model A looks cheaper, right? Wrong. Add the cost of human review. Assume $5 per failure. Model A, 2.5 cents plus 20% times $5 equals $1 and 2.5 cents per task. Model B, 5.1 cents plus 2% times $5 equals 15.1 cents per task. Model B is 85% cheaper when you account for the full workflow. The benchmark would have sent you to Model A. The real math shows Model B is the only viable option. Step 5. Rerun this quarterly. Models evolve fast. Your needs evolve too. Treat this as a repeatable process, not a one-off procurement decision. You can end this section by tying back to DeepSeek Math V2. It is a live example of what happens when you optimize for the right metric: reasoning quality and proof correctness, instead of chasing a public scoreboard. So when DeepSeek Math V2 launched last November, it quietly proved a point. Focusing on real-world metrics can create models that are better and cheaper than those built to win benchmarks. Since then, we've seen public criticism of leaderboards like LMArena, calling out how they distort incentives and reward style over truth. We've seen reports showing that large shares of enterprise AI projects fail to deliver ROI, mainly because companies choose and evaluate AI in the wrong way. That is why this story needed to be told now, and why it makes sense as the first episode of The Intelligent Founder. If you found this useful, subscribe and share it with one person who is currently making AI decisions based on leaderboards or hype. Thanks for listening.